Timeless Concepts from Physics Helpline. In this video tutorial, we will derive an expression for the moment of inertia of a solid cylinder about an axis passing through its center of mass and perpendicular to its length. Consider a cylinder of mass m, length L, and radius of cross-section r, as shown in the figure. The different steps of the derivation are as follows. First, we will choose an element of the cylinder which is a thin circular disc. Then we find the moment of inertia of the disc about a diameter which is parallel to the given axis. Then we find the moment of inertia of the disc about the given axis using the theorem of parallel axis. Finally, we integrate the expression between suitable limits to obtain the required expression. Now we will follow the steps. It is given that mass of the cylinder is equal to m, its length is equal to L, and radius is equal to r. This gives the mass per unit length is equal to m by L. In the first step, consider an element of thickness dx at a distance x from the given axis xy. It is obtained by cutting a slice perpendicular to the axis of the cylinder. Hence, the element is a thin circular disc of thickness dx. Therefore, mass of the element is equal to mass per unit length multiplied by thickness of the disc. Therefore, we have dm is equal to m by L into dx. It can be easily understood that the axis is parallel to the plane of the disc. Hence, there is a diameter of the disc which is parallel to the given axis xy. In the second step, we consider a diameter of the disc which is parallel to the given axis. It may be noted that in the figure, the plane of the disc is perpendicular to the plane of the figure. Now, let us recall that the moment of inertia of a disc of mass m and radius r about its diameter is equal to 1 by 4 mr square. Therefore, in this case, it is equal to 1 by 4 dm into r square. In the third step, we observe that the distance of the diameter from xy is equal to x. Now we apply the theorem of parallel axis. This gives the moment of inertia of the disc about the given axis xy. It is given by di is equal to 1 by 4 dm into r square plus dm into x square. Putting the value of dm, we get di is equal to mr square by 4l into dx plus m by l into x square dx. In the fourth step, the moment of inertia of the cylinder about the given axis can be obtained by integrating the expression between limits minus L by 2 to plus L by 2. Now, integral of dx is equal to x and integral of x square dx is equal to x cubed by 3. Putting the limits and simplifying, we get the final expression which is I is equal to mr square by 4 plus ml square by 12. we note that moment of inertia of a disk about a diameter is equal to mr square by 4. Here we get the additional term ml square by 12 due to distribution of mass away from the axis. For any clarification, please post a comment. Thanks for watching.